Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me, as usual, is Johan Oberg. Johan, how's it going this week?
It's another week, Chris. Great to be on the show. My week is as a normal week, which means I'm extremely jealous of you this week to be able to go to my hometown. Well, at least my second hometown. So I'm more interested in understanding how's your week.
Well, I'm back in London. I've been back here in 3 weeks. I think this is my second time here in 3 weeks. So it's nice to be able to travel and see my customers again and be talking to energy traders face to face as opposed to doing it on FaceTime or doing it on some video conference. It's great. It's nice and warm here, although it was kind of a gray day. We did see a little bit of sun. It's great to be in London. It's a lot of fun.
Fantastic place. As I said, a bit jealous. But another week, another show, another guest.
Well, interesting to be in the UK with our guest, right? So, what we were watching is a whole bunch of noise and information about gas prices, shortages, supply. And so, although we're not going to directly talk about that, we are going to talk about gas. And our guest is an expert in this. He brings some interesting technology. And so when he and I first talked in a pre-conversation, he talked a little bit of Internet of Things kind of stuff and pressure reading and gas lines and stuff. And at first, it didn't click to me of how this helps with renewables and how this helps with the whole story of what's going on. And so I'm hoping through today's interview, we figure out how having all these sensors and all the pieces that he makes with his company brings value to our customers and our audience.
No, I agree. And I think for me, this is especially interesting because it kind of connects my previous role with my current role. So
McDonald's.
as you know, exactly, not that far back. But that we are, with our team in Germany, we work a lot on biogas. Of course, we're an energy company, we're an energy trader, so we do some of the gas as well. But in my previous role at Telia, we built the IoT business. So the IoT has always been fairly close, and we launched products as the IoT in a box, which was the sensor pressuring kind of a software together with hardware combination. So I'm really curious to learn a little bit more about how they actually put this into scale and actually create value from what used to be back in the days, only a few years ago, technology only. So this is really looking forward to see the real values coming out of this now from these kind of technology themes.
Well, what we can do is we can speculate, or I can just introduce Adam Kingdon, CEO of Utonomy Ltd. Adam, welcome to the program.
Well, thank you very much for inviting me, Chris. It's a great pleasure to be here.
Well, we're excited to have you as our guest. As you can hear in our pre-conversation, we anticipate where you may go, but as Johan is apt to say, is we don't really know where the conversation is going to go, but we have some expectations, right or wrong. But before we go into the technology, maybe you could start by telling our audience a little bit about your background and who you are.
Well, my name's Adam Kingdon. I'm the CEO and the founder of a company called Utonomy. And I founded Utonomy back in 2015, very specifically to develop new technology to reduce the leakage on the gas distribution network. I'm sure you're aware that methane leakage is a real serious worldwide problem, and particularly because it's so much worse greenhouse gas than CO2. And but prior to founding Utonomy, I founded a company called I2O Water, which actually developed quite a similar technology, but for the water distribution network to reduce the leakage on the water network. And while I was running I2O, I had call from a couple of gas networks saying, we also have a problem with leakage, and maybe the I2O technology could help us as well. So we had a look at we had a look at what the gas networks were a lot different from water networks. So we ended up deciding to stick with water. But when I left I2O in end of 2014, I got back in touch with those gas networks and said, are you still looking for a solution to help you reduce your leakage? And they said, yeah, you bet we are. Yeah, this is a really important issue for us. And if you can come up with some clever technology and a better way of doing it, we'd be really interested. So that's what I founded Utonomy.
So when you say leakage, can you help me understand what that means and what causes it and where it's going? Is it just going to the atmosphere? What's happening to the leakage?
Yeah, well, it's some of the pipes still in the network in the older cities is still cast iron or and each. I mean, there's not a huge percentage of gas lost, but each joint leaks a little bit of methane. And across a whole network of thousands of kilometers of pipe, that can add up to significant amounts. And that methane is just released into the atmosphere. And obviously, methane is a terrible greenhouse gas. And over a 20-year period, it's about 84 times worse than CO2. Obviously, people usually talk about a 100-year period where it's about 29 times or 28 times worse greenhouse gas than CO2. But actually, I mean, given that we've got so many, we're really worried about the short term, and we're really worried that we're maybe getting some sort of tipping point. And there's quite an argument to use the 20-year figure of 84 as certainly as much as the 29 figure for over 100 years.
So if I go back a little bit to Chris' question in terms of how it actually works, and then probably a stupid question, but obviously you put on some kind of sensor data around the network, and that triggers where the leakage is. And how does it actually work, and how do you actually repel it, or how does this?
Yeah, I should have explained that. Yeah, what we're actually doing is optimizing the pressure in the gas distribution network, because the leakage is directly proportional to the pressure. So if you could reduce the pressure on average over the year by say 20%, you're going to have 20% less leakage. Basically, you're going to lose less gas through the existing joints and leaks that already exist in the pipe. So we don't actually fix the leaks, but we reduce the amount of gas that's lost out of the network. And managing that pressure is actually a surprisingly difficult job. And that's why that's why there haven't been solutions. Our solution hasn't been used before. It's a very tough thing to do.
So you talked in the pre-interview with me about the managing the pressure, and I think you mentioned that they send crews out to actually adjust, and in certain networks, because it was hard, would only do it several times a year. They weren't actively monitoring the pressure, or they weren't actively changing it. Do I remember that correctly from our conversation?
Yeah, well, that's correct, because the pressure that you have in the pipes, say in a city or a town, is controlled by thousands of gas governors. So the gas flows from the higher pressure tiers through a gas governor into the low pressure tiers, which are low pressure pipes, which distribute the gas to the houses. And all those gas governors have a fixed outlet pressure. I mean, they're completely manual. So if you want to adjust the pressure output, you go along there with they're sitting in a kiosk by the side of the road. You open the door, you go in there with a screwdriver, and you adjust the pressure by hand. And the problem with that is that obviously demand varies hugely throughout the year. So on a cold winter morning, you may have about 100 times the demand that you get on a warm summer evening. And if you're going to have enough pressure to deal with the cold winter morning, then you've got to set the governor's pressures very conservatively high. And that means that through the summer, when you've got less demand, or so at night or in the summer, you've got much lower demand. Yeah, you've got more pressure than you need. And all that excess pressure is creating excess leakage. So, and the bit you mentioned about manual control, well, the way they get over it at the moment is they have seasonal setting. So the governors will be on a winter setting, and so they'll be set pretty high to make sure they can cover any really extreme demand conditions in the winter peaks. Whenever the first thing in the morning, everyone's central heating goes on, there's a big peak. They've got to have enough pressure going into the network to cover that. So yes, and then when it comes to springtime, things warm up a bit. They don't need that pressure, so they send the whole crew around, thousands of governors, turning the pressure back down again. And then if they're not careful, they turn the pressures down, and then we have a cold snap in April or something, and they have to run around quickly and turn them all back up again. And it can take one network, up to 3 weeks using all their technicians to get around and do this job. So the first thing Utonomy system does is enable them to remotely control all the governors in the network, so they don't have to send people out to go and do it.
So I think that's really interesting, because the first one is obviously then to turn it off and on, which can be done manually or through a sensor or automatic thing. But then if I read it correctly, if I understand it correctly, obviously an AI or an Internet of Things does more than just on and off. So what are the other layers that you add to this apart from weather or kind of seasonal?
Yeah, I think you're very right to look at it like that, because that's how we look at it and how our customers look at it. We've got the basic system enables you to remotely control the governors, and then on top of that, we have our cloud hosted software which uses AI then to work out what is the optimum setting that each of these governors should be set at, and it's a really complicated problem, because so you have a town like Southampton, where we're based. It's got 25 governors all feeding the same network, and they all react against each other. And the demand is changing very fast, and it's changing a lot. And then you're trying to monitor a number of different points in the network to make sure you don't go below the minimum. So if you go below the minimum, then you risk someone's boiler stopping or cutting someone off, which absolutely got to avoid at all costs. So it's a really tough problem, and we've got some really clever AI people on the team, and we've come up with we think it's a very effective, good solution to that. But the hardware was a really serious challenge too, and we've had to in order to implement the solution, we've had to develop the hardware and the software. So the hardware is really, really tough. It's not just some off-the-shelf actuators and routers. We've had to develop the hardware ourselves, because to be able to control the governor, we have to retrofit some hardware onto the governors themselves, which are sitting in a kiosk, and they're potentially leaking gas, so potentially leaking methane. So you have to regard it as being an explosive environment. So we have to have our hardware certified to the highest level of what's called ATEX, which means that under no circumstances at all, no failures, no shorts, no faults of any kind could cause a temperature rise in any of the components, which would then trigger an explosion. So it's a really tough thing to do. And before we started, we found some papers that said you'll never be able to get ATEX Zone 0 with electric motors. But we got some smart engineers, and we found some very, very special motors, and we've been able to do it. And then you've also got no power there, and you've got no comms. And if anything goes wrong at all, it's got to fail in a safe pressure. You can't have it fail. You can't have anything go wrong, and either, well, certainly can't fail with an overpressure, because that would be very, very that would really risk safety. And you don't want it to fail and cut anyone's gas off either. I mean, that's not a great thing to do either. So we have to have a lot of redundancy and a lot of failovers, so that if any components fail, software hangs, anything like that, it fails in a safe, known pressure. So there's been a lot of really tough engineering going into the hardware as well as the software to develop the whole solution. And
so you talked about the hardware. You there's a little bit, you haven't yet covered the software angle of what you've had to develop. And so are gas companies going in and retrofitting then for reasons of just loss? Is it because they're worried about greenhouse gas? Is it because of cost of losing gas? Or what's motivating them to put your system in place?
Well, each market is a bit different, but in the UK, the regulator Ofgem gives some pretty generous. Well, probably people wouldn't accept them as being generous, but reasonably high level of incentives to get the leakage down, and then in the current price review period, they've mirrored that by they'll impose fines if it goes the wrong way as well. So the networks are quite incentivized financially. They also have to publish their leakage figures, and they've in the part of the price review period was to set a target for each year during that review period, and every year they have to publish where they are against their target, and they really don't want to be seen to be missing their target. I mean, it's very, very bad reputationally, and then obviously the cost of the gas price going up like it has. I mean, any gas that you lose through any form of leakage is going to cost someone 5 times as much as it used to cost them. So that's another incentive to get the leakage down. And
so now, is the gas coming from a central source, or how's I understand power grids pretty well. I'm not sure I understand the gas. So I get that there's a pressure. So I'd equate that to like a base load that you'd have to have there, that you want to have it. Where does the gas come into the system, and is your system involved in that?
Yeah, we're not yet involved in higher pressure tiers. I mean, basically the gas. I mean, certainly I know the UK better than other networks, but they're pretty similar in concept. So the gas will come in from the North Sea, although I think only about half our gas comes from the North Sea now, and then it's transmitted down the country in big steel pipes at about 70 bar, which are the transmission lines, like the 400 kV or whatever transmission lines, electricity, and probably a bit like electricity. It then goes into a lower pressure tier. I don't know, probably about 20 bar, 7 bar, then down to 7 bar, and to 2 bar, and then in the pipes in the cities is millibars. So but all that the other reason they're going to need control is because that like the electricity grids, that is starting to change. That used to be the gas just came in at one end of the network, and then it fed down through the different pressure tiers and came into people's houses through their meter. And but right now, the gas networks, I mean, the gas supply is getting more distributed, and particularly the first thing we're seeing is a lot of biomethane plants. There are over 100 biomethane plants have been built recently in the UK, and they tend to be built in the middle of nowhere. They tend to be built where you've got the feedstock, so it's in the middle of agricultural land, piece of in the middle of the farmland, and they have to connect into the nearest bit of grid. The nearest bit of grid may be the medium pressure, maybe it's 2 bar, or in the UK it's usually the 2 bar network they feed into, and so it's all working in a different direction, and they need control to be able to manage that. So that's the second big application for the Utonomy system, is to provide control in these medium pressure networks, so they can allow the feed in from the biomethane plants. And these biomethane plants also have a particular issue with the feed in, because if suddenly the demand drops on the bit of part of the network where they're feeding in, then they can't get the gas in anymore, and they've got no storage on site. They end up having to flare, which is hugely wasteful. So the networks are, we're looking at putting our system into this medium pressure networks, so they can get control of those medium pressure networks remotely, and also we're looking at AI solutions on top of that, so they can automatically prioritize the biomethane feed in at all times, so So any demand that is on that bit of the network is fed first by the biomethane plant, and the natural gas is there as a backup and is only used when the biomethane plant can't supply enough of the demand. So
one of the things when I worked with IoT and connecting things in one, if it was connecting the cars, if it was connecting the homes, or whatever it was connecting, you actually took from usually an innovative, smaller company, a startup company that had a very good idea, that had a solution to a problem. But there was always this crucial thing where connecting a third-party software, which might not be pressure tested, it has a direct connection to something that is business critical, in this case, the gas into our homes even. How does the gas companies look at this, where they're actually allowing, if I understand it correctly, your software to be connected directly onto the distribution or almost managing this?
Yeah, well, I guess there are a couple of things. I mean, firstly, the way we've designed our system means that there's also local control of the governor. So if the equipment of the governor loses connection with the central servers or the cloud-based software, there's no security concern at all. It carries on. It knows what to do, and then when it just doesn't upload its data, and it doesn't get updated with new schedules, but it can operate in a safe mode until it reconnects again, which means that if the comms fails, if the mobile phone network goes out, there's no safety issue at all, and likewise, if there's it can function without the central software. So if for example there's an outage on the cloud server, everything would continue to function safely. So that it's really part of the design of the system. But you're completely right. We're doing a pretty key job for the networks, and they're taking a very strong interest in the software and the way it's been built, and particularly the cybersecurity is a massive issue, and they do a lot of due diligence on the software. And although we're small, we got an engineering team around close to 20, but even so, we haven't built every bit of the software platform ourselves. So we've partnered with a big software company, Software AG, which already have an IoT platform, and we've been able to build our applications on top of that. So really, we've been able to use something like a middleware that does all the basic functionality of managing the devices and managing the databases and et cetera, and managing the logins for the customers. And we've built our applications on top of that. So we've got a very, very robust platform that's very well proven and supported by a very large company that we're running our software on top of, and I think that helps a lot. That's given some confidence to our customers, and
which I think this is an interesting topic, and we discussed this back and forth. There's one thing of connecting. We had a few shows ago, a while ago on the show, talking about the Colonial pipeline, obviously, and then how that was connected, and you got some of the other things. I'm always interested in one. I have no problems with the actual technology, because I think that's usually very good, the quality of the service. I'm always a little bit interested in terms of how the larger companies who are operating this business critical part is addressing a smaller startup, because we discussed that on the show a little bit in terms of the relationship between, let's call it the old legacy, versus the smarter or the new startups that scale up, the new technology, and how that interacts. Sometimes clashes and sometimes interacts. So that's a little bit also quite interesting for me to understand.
Yes.
How this works.
Well, of course, the other thing to say is that we've worked in very, very close partnership with our first customer, SGN. We'd never have done it without that really close partnership. I mean, almost from day one. So they've put a huge amount of effort into this as well, and we work very closely with them to make sure. I mean, with a lot of different points of view and some real experts on networks and how they operate and how governors operate and the safety issues. We've worked very closely with them to ensure that our product, is as low risk as it's possible to be for their network. And they've also got, I mean, the customer is SGN is our first customer on the networks in the UK. They've also got a very strong IT department, very strong IT team, and they know this is the way the world's going. They have a cloud-first strategy, for example. So they've already worked out what it means to put software safely in the cloud without risk. So working very closely with their teams as well has helped a lot. But right from the day one, we've been very aware cybersecurity is going to be a massive issue, and so that's every part of the design has been. We've been taking note of that.
So early on, would you say that your kind of prime customers almost need to have this cloud strategy in order to make this work, or?
Well, it's just a really efficient way of doing it, but fortunately, we've partnered with a company that's with Software AG. They have got the capability of taking the cloud hosted software and either putting it into a private cloud or on premise for the customer. So I mean, if the customer really wants to have their software where they can see it and touch it on premise, then we can do that. But it's probably a less efficient model.
Sure.
And,
so you talked a bit about AI and the use of AI. You talked about this software ecosystem and this partner you work with. So AI is a little bit of a buzzword these days. It means a lot of different things to a lot of different people. So maybe you could walk us through what kind of AI or machine learning, or what is the system actually using AI for? What is it getting smart about, and what is it doing? What kind of things?
Well, I guess that there are a couple of things we need to know to know how to set the pressures. And the first thing we need to understand what's going to happen to demand over the next 24 hours. So part of the AI or machine learning is getting as accurate as possible forecast of demand on a pretty much minute by minute basis over the next 24 hours, because that affects what the pressures we've got to set. That affects how we set the pressures. The other thing we've got to know about is how changing the pressure on each governor affects what's happening in the network. So we also develop real-time network. We also develop models of the network, and we combine those two things by combining those two things, and we can predict what is going to happen in the network, and therefore what settings we need for each of the governors. So it's probably more machine learning than anything else. But
and then, so is it? I get the weather or the prediction capability. Demand has inputs there. That the flow dynamics or understanding what the pressure in the network would do, is that something that you need to continually learn? Does a system change its behavior, or is it like physics? Is there certain laws that are just kind of consistent in how you expect it to behave?
Yeah, well, I probably shouldn't go into too much detail here, but it does change. That also changes over time. So we do need we need continuous data from the network to update all the models.
Cool. So another thing you mentioned is you guys have invented some unique or engineered unique switches or devices to governors and to control things. So what's your supply chain like? How do you get economies of scale if you're building these are you building them one off, or do you have them produced in scale are you growing? Or how does that work?
Well, we've partnered with a very strong subcontract manufacturing company, with capable of producing the product at quite some scale. So we don't do any manufacturing ourselves, and so they've been supplying sort of relatively small quantities so far. We've just equipped a couple of networks for SGN, which we've been running for the last couple of years. We're just on the cusp of moving into sort of commercial phase of the company, the commercial life of the company. So we're just working with the supply chain to scale up to much higher quantities, and so that's all part of the process of moving. Yeah.
How many of these does a network get? Are these like every quarter mile? Or are they every what number of sensors are in a network? Are these hundreds? Are these thousands?
Yeah, thousands. Yeah, I mean, in the UK, if we covered the whole of the UK, there'd be about 20,000 devices to control the governor. I mean, there are about 20,000 governors, and so to control all the governors, you need about 20,000 of these devices, and then you also need sensors out on the network that are measuring the pressures in the network as well, and sending that pressure data back, and probably a similar number of those. So it's not a huge number of endpoints for some IoT applications, but it's still quite a lot for us to manage.
But if it's 20,000 total, which is kind of the overall, and I know you're in the startup and kind of the initial stages of this, but obviously you don't do 20,000 at once. So what would be kind of an average, if it's possible to say in this early stage, but what would be an average project? If you go in the city of Southampton, for example, you mentioned a little bit in the beginning, what is a normal project? If there is a normal.
The first sort of rollout stage, so this beyond pilot, we're just finalizing at the moment with our first customer, and that's going to be around 700 systems. So that's sort of typical.
Is that system same thing as governors, or
system same thing as governors? Yes.
Okay.
So you need every governor. You need and that would do. I believe about 50 or 60 networks, so 50 or 60 towns or worth of governors. So so it's a reasonable start. I mean, it's starting at quite a reasonable scale. And we've been running pilots since the beginning of 2019.
So out of curiosity,
smaller scale.
Yeah. So out of curiosity, I put my business hat on and kind of drill in a little bit to the business case in this one. Where are you making the money? Is it on the hardware? Is it the kind of an operational part? Is it the software? Or a combination of both? I guess initially it's an upfront cost of the hardware, but how does the business case look like for you guys?
Well, for our customers, it's pretty good. It's payback. For us, we make it on normal manufacturing margin on the hardware that we sell the hardware, so as a capital sale, and then we supply the software as a service. So then the software is supplied on a sort of annual or monthly fee basis.
So you don't take a rev share.
Well,
all the money you save.
Well, it's interesting idea. There may be clients who'd be interested in that. But at the moment, we take a fixed fee for the software.
Yeah.
And so where does this software evolve to? So you're getting a bunch of data. You're going to have, as you grow your customer base, a pretty big historical database, I assume, at a certain point. Where do you see this going? Where does this change the industry, or what does this do? Where's your company helping drive the industry?
Well, I think in a number of different directions. I mean, first the first problem we've focused on is leakage, but then very quickly our customers said, well, actually we've got this bigger problem, which is we've got these biomethane plants feeding in, and in the future we're going to have hydrogen. How do we control the network enable that to happen. So that's the next problem we're addressing, and then there's also so really moving from leakage into hydrogen and biomethane, and then also there's a lot of other problems that we can solve using the data and AI from the network, and there's huge scope to do that. And so really the ultimate goal is to have a much more automated, as far as possible, maintenance-free network that's pretty much running itself most of the time, and that's absolutely achievable. So that's the direction we're heading.
Are you unique, or are there competitors? I mean, you talked about a fairly long development cycle. You talked about some intellectual property that you developed. So do you have competitors in this space?
Very little. There's one UK-based competitor that developed their solutions at the end of the 80s, beginning of the 90s, and there's still quite a lot of units. There are a lot of units in the ground still, but it was developed way before anyone thought of using machine learning or AI, and also it's quite difficult to install. You've got to replumb the governance station, and it's quite expensive to maintain. So we're the first that we know of with modern technology doing this, addressing this solution with a sort of modern IoT technology doing this solution, and also using these actuators, which are very fast to install in the governor stations. You don't have to replumb the governor station. You don't have to switch off the gas. You just you can retrofit our kit into the station in a couple of hours.
So is the gas market going to decline as we more electrify the world? And so I heard you say hydrogen is a possible future use, but is it a declining market? So, I mean, is it going to go rapidly downhill from being inside the industry because people don't want to burn fossil fuels or gas?
Well, yes, I'm sure there'll be the gas demand will go down as electricity takes over a larger share of heating in the home, et cetera, et cetera. So I'm sure we'll see that, but I think we'll see it at the same time a switch to low carbon gases. So to a big switch to hydrogen and a switch to biomethane. So that'll present significant opportunities for us because the network's going to need much more control in the network to enable them to bring in these gases into the network. And so where there may be fewer networks or there may be less gas transported, we think the switch to biomethane and hydrogen will keep us pretty busy.
So that's from a technology or a business point of view. You're based in the UK. You mentioned Southampton. You mentioned a few UK cases. Do you also review geographical expansion? Is there gas markets interesting elsewhere? Or I know UK is quite big for gas,
but very, very much so. I mean, our technology is applicable to any gas network really around the world, and we've had some really strong interest, particularly from the US. Particularly for the northeast US, where they have some old low pressure systems, where they're still using some metallic pipe, and they're also worried about their methane leakage, and are increasingly coming under pressure to do something about it. So we've had some really strong interest from the US, and also from Europe. I mean, even from countries where they have more modern networks, they still see value in being able to adjust the governors when they want to remotely. So, we definitely see a very big worldwide opportunity. But we want to do our first rollout at scale in the UK, close to home, with the customers we know well. But very soon after that, we expect to move to the US and to other European markets.
So, are you developing additional sensors or Internet of Things that go with the space? So, I mean, it sounds like you've got governors. It sounds like you've got pressure gauges of some sort. Are your R&D or your engineers working on new products or new value adds in the gas system, or is it all based on software going forward where the higher value comes?
Well, it's largely software. I mean, once we've got our hardware installed in the network, then we're able to control the network. We're able to collect data from the network. Then it's largely a question of developing additional further software applications to do new things for them. So we may need the odd additional sensor, for example, to if we want to measure flow, for example, we might need to insert additional sensors, but it's going to be mainly software applications using the data we've already got. We're already collecting and controlling the assets that we're already controlling.
So is your team more like what kind of engineers do you have of your 20 team members? Are they software engineers?
Well,
or are they...
I mean, that's we've got all disciplines. I mean, that's the challenge of developing our solution. We had to have some clever people doing a whole range of different things. So we've got some really smart mechanical engineers because we had to solve a really tough mechanical engineering problem. And we're going to need mechanical engineers going forward because every time we go into a new market, they've got a different type of governor, and we have to develop a new interface for the governor. So mechanical engineering is going to remain a skill for us. We've got electronics engineers, and particularly electronics engineers who know about ATEX are quite rare. So we've got a very strong electronics team. We've got a software team that has developed the software on the devices in the governors, and they also develop the software on the cloud platform. And then also we've got an AI team developing the AI solution. So, and then we've got a fantastic CTO who's been responsible for pulling that team together and also leading that team and coming up with the solutions. And it really has been a challenge. There's been a lot to do.
It sounds like you've built a pretty complex team to solve a complex problem. So did you have trouble finding investors that shared the vision to go along and saw this as a problem statement? I mean, you're a fairly young company, so I don't know if you're a private company or if you had investors come along. Did you have trouble selling the idea?
No, not at all.
To investors.
Yeah, no, the investors always get it pretty quickly. I mean, they can see that it's a massive problem, and we've got a solution to it that works. The investors really get it. I mean, obviously the downside of investing in our space is the sales cycles are pretty long, particularly in gas, where you've got to be very, very sure that it's safe before you deploy it. So there's a lot of extra checks, and no, they completely get the market, they get the technology, they get the solution. I mean, it's very clear to understand, and but they just have to be able to. They have to be a little more patient than some investors because of the long sales cycles. But it's going to be worth it because there's a very big market there, and the other thing is the big barriers to entry. I mean, because it's been a very tough thing to develop. We've needed a lot of investment from us. We've needed a lot of investment from our customer as well to get where we are. It's a bit harder for other people wanting to enter the market.
I always love to hear the business angle. Usually Johan's asking the business questions, but yeah. I think that's pretty interesting. I've got, as we're pressing up against time, kind of one final question from my side is, so what surprised you? What did you learn that you went into this and didn't think you would know? So you've been doing this, you've had trials for some period of time, you've got some live customers now. So what's the lesson learned that you didn't expect along the way?
Oh, loads of lessons. Absolutely.
Please share some.
I can, yeah. Probably maybe the biggest one. The biggest one that when we started, we thought we just need to develop one system, one solution, go and trial it, and then we'd be able to start selling it. And we then found that actually there were a huge number of different variety of governors in the network, and quite a bunch of them were under the ground as well. And our customers explained to us that actually there wasn't any point in being able to do half the governors in a network. you had to do all the governors in a network. So for the system solution to be deployable, we needed to be able to address these different governor types. So that was a bit of a learning. I mean, that's basically some due diligence we should have done better at the beginning. But we learned a lot. I mean, a lot of things. I mean, it's been quite a journey of discovery the whole last 5 years. And we've had some really tough problems to overcome. And the technical team done an amazing job getting over them. I mean, every time we kept coming against a problem and thinking, well, that is a real showstopper. I don't know how we're going to resolve that. And then after a while, eventually you find you have solved it. So we've got a fantastic team to put this product together.
I think that's. I thought it was really, really interesting. When I read up on it in the beginning of the show, I was kind of focusing on some kind of sensor data, but I kind of enjoyed discussion and learning about this pressure, which I didn't know before. But maybe one final question, and as Chris mentioned, I usually go into the commercial and the kind of sales approach around it. You mentioned the long sales cycles. Do you see them diminishing? Do you see them getting shorter and shorter because of your own technology and the way you deploy it? Or is the actual sales cycle, the long sales cycle, based on the customer's decisions? Because I think the sales cycles go both ways here. And you now have a proven case. The needs are there for the customers. So why is the sales cycle long, or so long as an obstacle?
Well, I'm sure it will shorten, and we're working very hard to shorten it by making it easier for the customer, by make sure all the information they need, all the technical data and everything they need is available to them really quickly and easily, so they can assess the product quickly. So we're doing everything we can, and also we've got SGN, who we've been doing our initial trials with. We've been very generous about talking to our new customers, sharing information with them, which helps. But at the end of the day, I think in my experience, all utilities have pretty long sales cycles just because the nature of their organization.
I second that. Yeah,
gas probably particularly because we've got the critical safety angle as well. I mean, they cannot deploy anything on their network till they're absolutely 100% sure that it's safe, and getting to that point sometimes takes time.
Yeah.
So I think we'd love to have the sales cycle a lot shorter, but I think we have to be realistic.
So I appreciate you answering that question. I think what I've learned, Johan, through our conversation today is when Adam and I first spoke and we were going to talk about sensor in the gas network, engaged, it didn't resonate super well with me at the beginning, to be totally transparent. And then as we talk more, and he talked about the leakage problem, so the immediate need started. That was interesting. That the getting biomethane and hydrogen and other gases and being able to handle them getting into the network and having the same kind of distributed input be different in a gas network than perhaps it has been in the past. That got my attention. And then as you move to the kind of data points that he described with the AI and with getting the forecast and really understanding and trying to predict what the pressure could be based on what's in the system, based on a bunch of factors that would be hard for an individual to do, but for a machine relatively easy to do if you have the right programs. I think that's all pretty cool stuff. So you take something that really kind of a solid state kind of thing doesn't sound exciting at face value, but when you put all the pieces together like you've done, Adam, I think it's pretty cool. I think it makes a difference, and I appreciate you sharing the story. That to me, hopefully I've repeated back what I've learned. I hope that's what you were trying to tell us. If I'm wrong,
very
please
much so.
call me out. But I think it's pretty exciting stuff, and I want to thank you for coming on the show with us.
Well, I'd like to thank you very much for inviting me. I've really enjoyed it. It's been great. Thank you very much, Chris. Thanks very much, Johan. And
great to have you on, Adam.
Yeah.
Well, for our audience, you've spent another hour listening to Insider's Guide to Energy. I hope you've enjoyed the journey as we've learned about the gas systems and pressure in the gas, and I hope you've enjoyed as much as I have. If you do enjoy these shows, please invite your friends to listen, share our link, and don't forget to subscribe to both your where you get your podcasts and to our LinkedIn channel. And we look forward to speaking to you again next week. Thank you very much. you.